The title of our presentation is Application of AR Techniques in Optimal Management of Battery Energy Storage System with Renewable Energy Resources. In this regard, our main research goal is optimizing battery energy storage systems, or BESS, by using AI techniques. And we will try to develop a strategy to identify optimal time interval for energy storage in battery energy storage devices. Here, I will describe our general model and scenario. In our scenario, we have an administrative building that receives some part of energy from power grid and other from the PV systems. Also, it's assumed that the building have access to some battery energy storage devices. In this figure, we can see the energy consumption from power grid and also energy production from PV system on the days of 1 week. In each day, it highlights appropriate time interval for BESS charging. In our scenario, these intervals align with PV production peaks and also when the energy consumption going to decrease in the building. In our case study, we have two data sets as a time series data. The first data set contains the energy production data from PV panel, which are reported hourly, and the second data set includes information on energy consumption from power grid that also present as a time series data. This data highlight the weekly change in energy consumption. This table presents the prediction performance metrics of two AI techniques, XGBoost and also LSTM, to prediction in our two datasets. The first table demonstrates that XGBoost have better performance for the data related to PV production. So we have choice to use XGBoost for prediction in PV system datasets. This table presents the prediction performance of these two AI techniques on energy consumption dataset. In this table, we can also see XGBoost has been selected because this method have better performance metric. So we have selected XGBoost for prediction in the energy consumption data set. This figure shows the actual and prediction result of XGBoost in both data sets. Based on the result of XGBoost, the predicted value for energy consumption and the predicted value for PV system production are illustrated in this figure. Also, based on our scenario, the suggested time intervals for BESS charging in each day have been selected. We suggest these time intervals when the prediction energy consumption is expected to decrease while the prediction energy production from PV system remains it in peak. Our study focusing in evaluating the effectiveness of AI techniques on energy consumption and renewable energy production data, and our objective was identify optimal time intervals for BESS charging. And we finding that the XGBoost techniques show the better performance in these two data sets. And for our future work, we will try to explore the impact of weather parameters and also incorporate multi-year data sets to refine model training.